Good morning, students. I'm Dr. Vijay Bhandari, Associate Professor in SIRTS CSE Department. So now we are going to perform experiment number 2, and we are going to learn find out the best fit line using multiple regressions. So before we go into this, so we we should import some libraries. So import matplotlib.py plot splt. So we are importing these libraries and import numpy as np, and from sklearn import data sets linear model method. So here we understand the sklearn library. So sklearn sometimes it is probably the most useful library for machine learning in Python. The sklearn library contains a lot of efficient tools for machine learning and its statistical modeling, including classifications, regressions, clustering, and last one, dimensionality reductions. So now we move into next cells, load the Boston data sets. So before this, I'll show you something. This is the Jupyter lab, and now we are going to perform on this platform. Okay, so this is processing. It takes less time. So we work on cell windows. Okay, so every cells what we type here, so it's kernel execute here. Okay, so this is the kernel, and kernel you can restart the kernel and clear all the outputs and shut down the kernels. So it depends on you. Okay, so now we are importing matplot, numpy, and sklearn. Okay, so in next cell, loading the Boston data sets from the QCI machine learning websites. So this is the data sets. Okay, now in next cell, defining feature matrix and then response vectors. Okay, so now X is taking, we are taking the X variable, and which is Boston data is storing, and Y is Boston target. So these are the two features. One is feature matrix and second is response vectors. So now in next cell, splitting the X and Y into training sets and testing sets. So we are creating our class, importing the train test split from sklearn model. So as we know that, what is sklearn used for? Scikit-learn is probably the most useful library for machine learning in Python, as we know that. So the in this we are taking the x train, x test, y train, y test, then splitting into a two sets. Okay, so x and y. We are taking the testing set size is the 40%. So we are taking testing size 50%. Now in next cell, we are creating linear regression objects. Now we create the objects reg, and we are using this method linear model linear regression, as we have seen in experiment number 1. So what is it? Linear regression. Linear regression is fitting the best line and find out the best fit line. So these are the data points are near to straight line. Okay, so when we put the data into a IM line, so we use linear model, linear regression. So in next cell, train the model using the trend set. So we are using here regression dot fit method and using on next trend right. Now we are calculating the regression coefficients and taking coefficients. This is the new line operator and make an reg dot coefficient. So it calculates the coefficients. Yeah, so there are a number of independent variables. Okay, and attaching with the coefficients, and the coefficients having a high factor, so that particular independent variable having an access score. Okay, so this is the variance score. One means perfect predictions, zero means zero means is neutral predictions. Okay, so there one means perfect predictions. Data points will be near about the straight line. So this is the format of having plot score x test and y test. Now we are plotting the residence errors. Basically, residence errors is difference between the observed value and predicted value. So setting the plotting style in next cell. Okay, so PLT dot is scatter, REG dot predict X train, and REG dot predict X train as Y train. So this is we are calculating here R square. Okay, so this is the least square error. This is denoting as a green point, and labeling is equal to train data. So we are level here. Now we are plotting the graphs and is equal to upper right and natural errors. Now function should plot PLT dot show, it shows the plot. Okay, so now the result is here. You run this code and find the results. This is the coefficients. Coefficient is like minus 8.95, 6.73, 5.04, 2.18. This is the coefficients. And variance score is 0.72. So this is the good variance score near about the 1. Now we can show this plot. There is a train data and test data, as we have discussed in this code. Train data and test data. So we are taking the 40% of the test data to the training data. Okay, so this is the line which is dividing the data points. There's a train data and test data. Train data is denoted by the green points and test data is blue points. So this is the multiple regressions which we have discussed in this session. So hope so you might be understanding this code and this techniques multiple regression. Now we will see experiment number 3 in the next session. So if any doubt, so please ask me. Okay, thank you. Thanks for today.